Hello again. Now that we have a clear understanding of what the parent functions that we'll be using this year are, we're going to take a look now at the transformations that affect them. Please understand that you're going to do the same thing no matter what parent function you have. So notice you have this generic f of x here in front of all of these. Regardless of whatever the parent function is, you will still apply the same transformations to it. It's easy to get confused or get lost, but as long as you keep it clear where each one of these are, then you'll be able to clearly understand how they affect the graph. I'm going to refer to some things known as inside or outside, or same or opposite. Okay? Inside a function, notice that's number 2. You've got the transformation itself occurring within the parentheses. Those will be inside with the parent function. Notice here we are outside the parent function. And outside means that your transformation occurs outside of the parentheses, which means it's outside of what would be known as the parent function. Notice also that when you have a value on the outside, you have a downward motion when the value is negative. Likewise, you have an upward motion when the value is positive. When we go down here to number 2, you'll notice that the value inside now is all of a sudden opposite. If I think for a second about what negative numbers do on a number line, I think that negative numbers will move my value to the left. But in this case, it shifts it to the right. And there's where that term opposite comes in. So outside will have the same effect as what you would think. Inside will have the opposite effect of what you would think. All right. So now that you've had some time undoubtedly to copy this down, if you have a transformation of minus d units on the outside of a parent function, it's going to shift it down. Plus d up. Next thing we're going to do is we're going to explore what happens when it's on the inside. X minus c, x plus c. So it'll shift it to the right if it's a minus, to the left if it's a plus. We're going to spend some time exploring this a little bit further, but if you have your calculator with you and you want to try these transformations on your own to see how it actually works, go ahead. Number 3 and number 4 will be where we go next. Notice that we have now multipliers. Multipliers will occur either in front of the function or inside the function next to the x. Again, we're affecting a up and down change if it's on the outside, and a left and right change if it's on the inside. That is going to be consistent for all transformations. Anything that's on the inside of parentheses affect the x values. X values will move a function either to the left or to the right. Anything that's on the outside, as in number 1 and number 3, will have an effect on the y values, and the y values will change the graph in an up or down motion. A's, when a is bigger than 1, which this makes sense. When I have very big numbers, I'm going to get a stretch. That is the same effect as what I would think. When I have a fraction between 0 and 1, I'm going to get what is known as a compression vertically, and that's going to occur by the factor of a in both cases. Down here, we're going to talk about the horizontal compression. Now you got to think about this as an inverse property. The best property I can give you that shows this is water pressure. So as you go deeper underneath the water, if you were to take a cup down with you or a water bottle that's filled with air or anything like that, then you'll notice that the air inside of that airspace compresses. So as the pressure increases, we get more of a compression here, which is the opposite effect of what I would think. Okay? A compression normally means smaller numbers, but in this case, since we have that very heavy water column affecting that small amount of air inside of our water bottle example, you get that compression. So when you have a fraction, you'll get actually what is known as a horizontal stretch. Now as we go throughout the year, you're going to see less and less difference between these two things, a vertical stretch and a horizontal compression, and a vertical compression and a horizontal stretch. In a lot of cases, they're exactly the same. It's all placement on the value of the number. All right, the last one we're going to deal with is what happens when there's a negative value. So if negative value on the outside, we're going to reflect the graph from up to down, and that's across the x-axis. If it's on the inside, we're going to reflect the graph from left to right. or from right to left, whichever it goes, and that's across the y-axis. All right? And now what we're going to do is going to get into a couple of examples here so you can see how this works, okay? So in example number 6, we're going to take this little star and we're going to use that to help us find the order of our transformations. So we're going to move from left to right. I'm going to go up to my original function, which I see here is h of x. I'm going to see that there's a whole bunch of transformations that occur in it. Really quickly, I'm going to think about what those are. All right, the negative on the outside means I got a reflection from up to down. The 2 means I've got a vertical stretch, and the +1 means it moves up 1. So I took the liberty of creating each of these transformations so that we can move through them pretty quickly. All right? So moving from left to right, I'm going to begin with this, my first transformation. Notice that what was down is now up. What's up is down, down, up, down, up. And then I connect those dots together to give me my first transformation of negative. The next thing I'm going to do is I'm going to affect the change here with the 2. So I'm going to come over here and notice what happens. What was 1 is now 2. What was 2 is now 4. What was 4 is now 8. And what was 2 is now 4. All right, so let's talk about what that means here so that you can clearly see what I'm talking about. Notice the distance from the x-axis to the blue line is 1. Notice the distance from the x-axis to the blue line is 2. Notice the x-axis to the blue line here is 4. And notice the distance here is 2. Well, if I have a vertical stretch of 2, that means all of these values are going to be multiplied by that vertical stretch. That's what it's meant by a stretch of a factor of a. So now notice that what was 1 is now 2, what was 2 is now 4, what was 4 is now 8, and what was 2 is now 4. And then I go ahead and connect those dots. That leaves us with one very important transformation, and that's up 1. That's what the purple line is reserved for. So I'm going to take that purple line and I'm going to shift it from the red line exactly 1 unit up. And there's my final transformation right there. And that would be the end result of what I was looking for. So if I needed to graph, this is what my end result graph would look like with everything else out of the way. All right, let's try again. On this one, we're going to enter in a new set of transformations. Now, this can be confusing because in some cases the transformation is absolute value, and in other cases the parent function is absolute value. All right, so you're going to want to really look at what the original parent function is when you're trying to determine whether it's an absolute value parent function or an absolute value transformation. But because today we're talking about transformations, this is an absolute value transformation. So there's going to be 2, just like before, and notice that if the absolute value is on the outside of the actual function, y values are the ones that are changing. So it's still going to be consistent with what we talked about. Notice that only negative y values are changed. So you'll see this guy right here is a negative y value, and the rest of the graph is as well. So I've gone ahead and drawn this guy in, and I'm going to go ahead and apply these transformations like so. So everything that's negative, everything that's below the line, becomes positive above the line, which is consistent with what absolute value does. Okay? And of the 2 transformations, this one is definitely easier to understand. Everything that's above stays the same. That's why this blue line has overwritten the black line there, and now all of the others get reflected above the x-axis. All right, number 9, it gets a little bit different. Okay? Number 9 is what is known as a mirror image reflection. Okay? So we got some negative x values, and they get erased. And then what goes in their place is a mirror image reflection of all of the positive x values. Okay? So I found it, I hid it over here, but it's white, so I might have to take a few minutes to find it. Where is it? There it is, found it. All right, so I took the liberty of drawing in some white lines here, to erase the negative x values. All right? And then I'm going to take the mirror image reflection of the positive ones. And here is what the actual graph looks like. So I erase these ones that were negative, take whatever's over here, reflect it over the y-axis, and there's my new graph. That one is a little bit tricky. We're going to do some more practice on that, but that's what absolute value looks like. All right, we've got a couple more that we're going to do before we finish up. Okay? So it says, given the original function of h of x, name all the transformations. All right, so that means I've got absolute value on the outside, so that's going to be reflect all negative y values. Oops, if I could spell values, that'd be great. Over x-axis. Okay. And number 2, notice the parentheses end here, which means the 2 is still on the outside of the parent function, which means I have a downward movement 2. All right, I come over here. Ooh, we've got quite a few. So I've got the 2, I've got absolute value bars, the 1, and the 3/4. So I'm going to take them from left to right. All right, let's start with the 2. That's on the outside of the parentheses. That would be my vertical stretch by a factor of 2. I've got absolute value. Remember, that's that mirror image reflection. So that's a mirror image reflection of all positive x values. And then I get to the negative 1. Notice it's still inside the parentheses. Inside is opposite of what I think, so that's going to be a right movement of 1. And then my parentheses end, and then the 3/4 shows up. So that means it's the same, and it's down 3/4 of a unit. All right, we're going to write an expression representing the following formula. H of x, vertical compression, horizontal translation, and vertical translation. All right? So vertical compression means that it's going to be on the outside of this. So I start with 2/3. Now I'm going to write h of x. Because I have a horizontal translation, that means the 2 goes inside. Now the number is positive because it's opposite of what I think. Vertical translation means I can close my parentheses and add 7 to the outside. Now what we're going to do is we're going to write an expression that helps us describe the transformation of this graph to that one. All right? So I'm going to say, first of all, that g of x, that's my transform parent function, is going to be f of x with some numbers added to it. Okay? So I'm going to take some critical values here and look at those movements. So I'm going to first think 1, 2, 3. Well, that's 3 units right. And then I'm going to go here, 1, 2. Well, that's 2 units up. So that means that the up goes on the outside, the right goes on the inside. So g of x is going to be f of x after I make some transformations to it. Remember, opposite of what I think on the inside, and then the same of what I think on the outside. And there is your movement. We're going to spend a lot more time working with transformations. So if you don't feel really comfortable just yet, come tomorrow prepared with some questions so that we can answer those questions, but just be really ready to practice as much as you possibly can so you can feel comfortable with this after we get done with some particular practice time.